Okay, hello. My name is Duane Dorch. I'm with Compuware Corporation. Compuware is in the application performance monitoring space. One of the divisions of Compuware, Gomez, focuses on web performance and web load testing. So my expertise, my background is in load testing. I've been in that space for about 25 years and have seen a lot of both products, processes, and tools for load testing. And I think today might be good just to talk about the standard load testing process and some approaches to doing load testing for web-based applications that may not be commonly known, or at least some best practices that we've seen in working with our high-volume web customers. So in general, when we think about load testing, there are really four major processes or four major steps that we go through in a load testing exercise. The first is obviously to generate the load that represents real user activity. And there are a lot of tools and processes in place that can do that today. The second step is to analyze that load and try to figure out where the bottlenecks are. And that's really where we spend the most of our time and it really requires the most extensive resources within the organization. The third step is to then communicate our findings with developers. This can often be a challenge, especially if our developers are third-party developers or offshore developers, or even in large organizations where your developers are spread out around the country, around the world. And then the final step is rerunning load tests. Once the developers have made their changes, you want to run a test and ensure that those changes actually fix the problems that they were intended to fix. So let's just kind of walk through each of those four steps or those four processes briefly. The first one is applying a load on the system. There are many traditional tools in place today that can help you to put a load on your system. And when we look at how load testing has evolved over the years, we've really spent most of our energies on this first step, which is putting the load on the system. The tools have all focused on ways to make it easier to put a load on the system. But when we talk to customers and ask them, what's the real purpose of load testing, or what's your goal in a load testing exercise, people don't really talk about, well, I need to be able to apply a load onto the system. That's kind of a given. The real goal of load testing is really to understand where your bottlenecks are so that you can fix infrastructure problems, you can fix application problems, fix network problems. So really that second step that we talked about is really the most important aspect of the whole testing process. But we tend to spend our time on that first step of generating load, right? So let's talk about that first step briefly. It's important to put a representative load on the system, one that represents real user activity. And there are a couple of ways that we've evolved in our ability to do that. The most traditional and best known tools are those that run internally. They will generate traffic inside your firewall, and those types of tools are great for helping you understand application and infrastructure problems. But if you're dealing with a distributed web application, they really don't help you to understand how your end users are performing, and they don't tell you anything about the components of the application that are outside of your firewall. Things like third-party, whether it be advertising, plugins, CDNs, those types of third-party sources that reside outside your firewall. So just testing with internal tools is really not sufficient for helping you understand the performance of a distributed web application where users are all over the world. So the other approach that is gaining much more popularity is the ability to test from distributed locations using some type of a distributed network. Whether it be Compuware's network or others, there are networks out there that will allow you to run load tests from distributed locations around the world so that your load is now coming from diverse geographical locations, and you're able to test out performance from these general locations and understand how your third parties will perform under load. Okay? So it's important if you're testing a distributed web application that you really choose a tool that will allow you to test from distributed remote locations. The second step, again, one that I think is the most important step, is understanding the performance of your applications and your infrastructure once they're under load. Right? This is really gets to the goal of our whole load testing exercise, and it's important that you understand the tools that are out there that can help you to pinpoint bottlenecks while the system is under load. Most people that are involved in load testing will put together a patch of various types of tools that will monitor the network, the database, the applications, the servers, and try to piece all this information together. Or there are other tools on the market that will allow us to, within a single solution, be able to automatically analyze the entire infrastructure and help us to pinpoint exactly where those problems are while our application is under load. Okay. The third step in this process is understanding where those problems are and then communicating those issues to your developers. Ideally, your tools that you're using are those that can be shared with developers so that you're communicating real data, real facts about the problems that you find, as opposed to anecdotal data or kind of word of mouth or rerunning a load test so that your developers can look at it. So it's important as you're analyzing various load testing solutions to try to find something that can share information between the testing organization, but also allow the developers to be able to use that same information to drill down into the infrastructure, into the network topology, into the application layer to understand exactly where those bottlenecks are. So now we're tying together the testing process with the development organization so that we're able to very quickly analyze and solve these problems. That final step of rerunning tests and re-executing tests is also important, and your tools should also be able to support your ability to compare results between a first test and the subsequent test so that you can automatically compare the first run to the second run, understanding the differences in performance and the differences in your infrastructure, making sure that the changes that your developers made between runs are really fixing your problems, and that it can point out the differences between the two runs. So the ability to have some automatic regression analysis between test executions will really help you in understanding and ensuring that the changes that were made between tests are actually productive changes and will impact your users in a positive way. So as you're going through looking at the tools that will support you in this environment, make sure that your tools can help you in all four of these areas. And the benefits that you'll derive from efficiencies in these areas are, number one, you'll be able to be able to run less testing because the testing that you're executing is more efficient. Number two, your communication with your development organization is going to be much more effective, which means that they'll be able to find and fix problems much faster. So part of the load testing process is obviously applying a load that represents real user activity. In order to do that, you've got to have some automated scripting technology that you use. Compuware provides a script generation product called GROMES Recorder that will automatically capture the activities of real users. So you will sit down, you first of all have to define what your test plan is, understand the scripts that represent your real user activity. Once you have that documented, it's very easy to turn on the script recorder, walk through your transaction as you normally would, and capture all that interaction between the user and the browser. Our script recorder automatically converts that to a script that can then be uploaded to our network and played back. When we play that script back, it runs it just like a real user would. Your system thinks it's talking to a real user and responds accordingly, but our script is the one that's running, and we can measure the performance times, the response times between the script and your system. So it's easy to see how you can do that from a single user perspective. You capture a script, it represents real user activity, you play it back as a single user. But you can then push that script out to our expansive network so that now we can have this script executing from multiple locations around the world and representing multiple users. So let's say that you're a US-based retailer. You have traffic coming from evenly distributed across the US. You can push this script that you've captured to our network of nodes across the US, and at the defined time we'll execute that script against your environment from our multiple geographies. So we've got actually two sources that we can use to generate this load. We've got what we call our last mile, as well as our data center locations. Our last mile is a network of over 150,000 real desktops in people's homes and offices around the world. And they sign up to be part of our network. That allows us to download the script that you want to execute to their local machine, and the script will run from that machine, going through their local ISP, providing you with real end-user performance response time. In exchange for letting us use their system, we deposit a small amount of money in a PayPal account at the end of every month for them, depending on how much we've used. So at the end of a month, a typical customer will have $5 or $6, something to buy a pizza with. But it really allows us use of a very extensive network of computers all around the world.